So validating with meaning, syntactic and semantic validation of the E-ARK SIP. It sounds perhaps a bit fancier than it is, but you need a spectacular title to get people to these webinars. So here we are. So today's story arc, I also included some puns on the E-ARK team to make it a bit more fun. So I'll just briefly introduce who meemoo is, so the organization I work for. Then some more context about how we came to use the E-ARK SIP. Then delving or diving, to remain in the team, a bit more into this SIP that we call between quotes the meemoo SIP, because we added a little twist to the E-ARK SIP, and then how we ingest them, and then just a brief section at the end about way forward and lessons learned and stuff that we are still thinking about how we could do differently. So I'll go quickly through these slides because some people might have seen them already. So meemoo is the Flemish Institute for Archives in Belgium. So we have our service provision consists of 4 pillars, basically, as you can see on the slide. So we do digitization, or we provide support for digitization, digitally archiving and managing archival materials. We make the digital content resulting from these operations accessible and usable, and keep it readable, and watch its integrity in our meemoo archive system. So for example, we have the digital archive of the VRT, so the largest public broadcaster in Flanders, I believe. We do this together, of course, with our content partners that we also call CPs, and we use various platforms for this. We also like to gather and share expertise, hence this webinar, and answer requests for advice about digital heritage processes. And we set up many projects to collaborate with other cultural, media, and heritage institutions. So this is just a visual representation of our content partners. So we collaborate currently with more than 180 partners across Flanders. So you can see them geographically there. And these are divided in a number of sectors that you can also see. So this basically ranges from museums to public broadcasters to heritage libraries. So a big spectrum of potential partners. Currently, we have about 182. An important side note at this point is that given the many sectors that we collaborate with, this results in many heterogeneous metadata models, practices, and wishes, which will be interesting further on in the presentation. So at the moment, we have just some figures, like a bit of a humble brag, as you wish. So we currently have over 8 million objects in our archive system, which results in about 26 petabytes. We have transferred since the beginning in 2013, because meemoo is about 10, 11 years old. We've transferred over 540,000 audiovisual carriers, so physical carriers. And we also, on one of our dissemination or access platforms for education, we have currently about 185,000 teachers, students, and trainee teachers that make use of the audio and image content that we give at their that they can use basically for their courses. So for example, for Dutch or for history courses in primary or secondary school, teachers can use materials, of course selected materials, to enhance their teaching material. But the focus today will be on how we use the E-ARK SIP in our ingest processes, with a focus on the semantic validation part that we added. So just a brief overview of our infrastructure. So I think that if I do, I think you can see my cursor. I hope so, at least. So at the basis, we have our content partner here at the beginning, which can deliver material to us either via large-scale digitization projects. So we collect, or they collect, analog carriers in batches, and then these are digitized by service providers after a number of tenders, which are then delivered to our media asset management system. Content partners can also deliver born digital materials to us, so they can deliver these in large batches of multiple materials, which we have project managers that guide them through this process. So this is more like a manual guided way of doing stuff. And then we also have a continuous flow in which the partner integrates directly with our or the API of our media asset management system, and they can basically continuously and automatically deliver material at their wishes. So if we move a layer up, so then you have the media asset management system that we use. And then on top of that, we have a number of integrations for different purposes. So of course, we have a REST API. We also offer search, then also a GraphQL and an OAI PMH API. And then on top of those, we have our interaction platforms. So the different dissemination platforms that we have. So we have the archive for education, then News of the Great War, which contains digitized newspapers of the world wars. Art in Flanders is also a big one, which contains digitized paintings and other artworks from museums in Flanders. And then we also have some internal tools and also applications of CPs, which is a content partner that directly run on top of these integration layers. So this was the intro, perhaps a bit fast, but if you have any more questions, you can surely ask them at the end. So a bit more context, how we came to the realization that we actually needed something like a standardized SIP, so a submission information package. Over the years, because you can see that we exist since 2013, we noticed an increase in the number of partners. So you can see here in blue each year how many partners joined us. And then in green, you have the cumulative numbers. So we started with like 46. Then we upped the number significantly with the large scale digitization projects that we manage. And then in the last couple of years, we noticed a significant growth, especially with the material that was delivered via born digital archiving. So like digital influx or archiving in which is a bit tricky, of course, because with the digitization projects that we managed or that we still manage, we can impose via tenders specific requirements or constraints on the service provider. So we can very specifically ask them or tell them to deliver material in this specific format, which works nicely because then we have more control. But now with this born digital archiving or digital influx, whatever you want to call it, we cannot impose the same constraints as the requirements we were able to for the service provider. So we started to see a problem in the scalability of things. So this is just a slide to illustrate a number of tools that our project managers and ourselves use on a daily basis for this influx of digital collections, just to highlight a bit of the complexity and the manual aspect that comes into play with this. So they can deliver, or previously they could deliver stuff on FTP and S3. Nowadays we moved, I think, permanently to S3, so that's a bit simpler already. But then you also have tools like Droids for people who don't have information about their file formats and their integrity. Then some people are quite technically savvy and they can use XSLT to transform their metadata into the desired metadata that we need. Other people are not that tech savvy and actually still work with spreadsheets, for example, or templates that they fill in manually, but also the example that they use with Droid. So you can see that this is quite complex and a lot of manual work. And then more importantly, perhaps, we also noticed or experienced an increasingly diverse and complex number of object structures. So previously, things were relatively simple, of course, with a number of exceptions. So we digitized for example, some audio reel or some video or whatever, or that was quite simple because you had one single, as you can see here, for example, a digitized picture that is just basically a JPEG or a TIFF and then some XML with the metadata about this picture. But once you start getting stuff like newspaper issues, yeah, it becomes a bit more complex because you have these different hierarchical layers in which you have the issue itself on top, or even if you go broader, you have the newspaper series of which the newspaper issue is part. And then, of course, the newspaper issue has different pages. Each page can have a separate XML file. Then you can also have an auto XML file, so the transcribed content of a page. Then you can have a high resolution TIFF, or perhaps even a PDF or a JPEG or whatever. So you start to notice a number of problems with this. I'm just checking. The colors are, of course, not representative of anything. It's just to add to the feeling of confusion that we also experienced. Then, as I already told you briefly, we have a lot more heterogeneity in the metadata because we have an increasing demand for descriptive non-audiovisual metadata fields, because most of our existing metadata previously was based on audiovisual content from the regional and public broadcasters. But yeah, of course, those kind of metadata fields are not necessarily interesting for museums or small cultural heritage institutions. So this led over the years to a number of ad hoc solutions and new metadata fields or terms sometimes being introduced without thoroughly exploring the available schemata or metadata models, because we needed quick solutions to be able to deliver to our partners. And overall, we needed a new way to structure all of this to impose specific and especially clear requirements to our partners in order to streamline the different processes and the different metadata fields. So now I can relax a little bit more. So this was basically a bit of introduction. So I will start with a deeper dive into the meemoo SIP between quotes specifications, because we don't really like the name meemoo SIP, because it's not like we invented something like the SIP as a concept, or even the specifications that we use are mostly based on E-ARK, but it's just easier to communicate to partners that we don't just accept any SIP, we impose the use of our SIP between air quotes. I think often people don't realize the joke on this one, but yeah, as you can see on the picture, it's a number of divers that are preparing in ancient times to go under the water. So this is the feeling that you should get in the next couple of slides. We manage our SIP specification on our developer documentation. You can find all the relevant URLs at the end of the presentation that will be shared, I guess, or is already shared. So no need to quickly type this over or anything. Our meemoo SIP specification is rooted in the E-ARK initiative. As you probably know, otherwise I don't think that you would be here at the moment. E-ARK offered a new uniform SIP design that had a number of qualities that we were actually looking for. We needed a SIP that was based on standards, yet flexible enough to handle the unknown demands of the future with new content types, new types of objects. So we needed some sort of extensibility. It needed to have a formal and mature specification, as you can see, that we could implement ourselves while still using standards, of course. These standards, the ones that were particularly interesting to us, were METs and premise, because we already used them. And METs premise matched well with how we actually wanted to describe the object structure. And we also heavily rely on Premise OWL for another project that I could talk endlessly about, in which we are currently still migrating our metadata infrastructure towards a knowledge graph. So basically a linked data representation of everything, for which we also use premise OWL. And we wanted something that aligned well with our partners. So we needed something that was at the moment still XML based, because they are currently best acquainted with this format. So if we would need to explain to them, for example, I'm just saying something, how JSON works and how you should form a correct JSON and use the fields in there and the keys and the values and whatever, it would get us off track again. So we wanted something that was XML based. I also added the XKCD comic about the proliferation of standards, which most people will know, I guess, because we didn't want to reinvent the I don't know how you say it in English, but the hot water, so to speak. We didn't want to reinvent the wheel. I think that's the correct impression. So it was important that we could rely on something that was already there and that was used by the community. But of course, rooted in the E-ARK initiative, notice the 3 dots, but with a layer of course, not secret, but it made it a bit funnier, not so secret memo sauce, because the E-ARK specification is really nice, of course, if you're perhaps a bit more technically savvy. But we have a large number, I think the majority of our partners, that are not that tech savvy. So we have a low number of tech savvy partners, and the flexibility that we desired as an organization can actually lead for them to complexity. So we needed more rules regarding the object structure and the descriptive metadata that was used in the SIP. And the E-ARK specification itself was, in our opinion, not very readable unless you had a lot of background already around concepts like a SIP, like premise, like mets. So we actually added sections in the documentation that I showed you previously, in which we introduced them to the terminology used in the specification, in which we have a section about the core concept. So we introduced them to premise and how premise uses these concepts or terms like intellectual entity, the representation, the files that are also heavily present in the E-ARK specification. And then most importantly, perhaps for them, we also added use cases. So they can actually read those use cases. They can think about the use cases, so they can visualize, so to speak, like we have this type of material. What fields should we actually use or not use in the specification? And then, so we required the use of premise XML because we relied heavily on this already previously. And then we conceived, so to speak, the concept of content profiles, which are a bit like the CITS, so the CITS profiles that E-ARK has themselves, which are, in our case, additional use case driven constraints that are often domain or material specific. So we started from a generic base, so to speak. I'm using a lot of so to speak, apparently. We started with a generic base that is the E-ARK specification. And then depending on the type of material that a content partner wants to deliver, we added the content profiles, and each content profile, for example, we have a bibliographic content profile. Perhaps it will be clearer on this slide. We have a bibliographic content profile in which partners can or actually must use the bibliographic metadata from MODS, because that's a standard that is very well suited to these kinds of objects, and in which they can have different intellectual entities. So for example, if you have a newspaper edition, that can be an intellectual entity because you can have metadata, descriptive metadata about the edition. So this edition belongs to a specific series, for example. It was published on this specific day, and then you can, this intellectual entity, so the main intellectual entity can consist of other intellectual entities. In this case, for the bibliographic profile, the pages, because the pages can have their own metadata. They are numbered, so each page, for example, has a page number that is specific descriptive metadata for that page, and then each page can have a number of different representations, because a page can have an archive master in TIFF format, for example, that you want to archive and from which you can derive the JPEG or other formats that you want. But the page that is scanned can also have a transcribed representation in the form of the auto XML. So basically applying OCR on the TIFF to get a purely text-based representation of that page that can then be very useful to search through the page in an interface or in a UI. And then you can have a different number of files underneath each representation. And then other ones include a very basic content profile in which we limit the partner to one single intellectual entity with one single representation with multiple files. So that could be a single digitized picture that is a single intellectual entity. So the picture and what it depicts, and then it has a single representation that contains a high quality scan or something that consists in this case of a single file, but you could also have a video that has also the subtitles that go with it. That's then one representation, but with multiple files. And then the most recent one that we introduced is, I see that I forgot something on this slide, but the most recent one is the content profile for digitized film. So actual film reels and audio reels that are contained in this film, in which we have one single intellectual entity, so the content of the digitized film, but you have multiple representations, multiple files, and also specific to this profile is that we, like in Premise, if you know Premise, you have these, yeah, it will become clearer afterwards, I think. This is the editorial process that we use at meemoo internally. So we divide the work on our specification and everything in the backend for ingest that will come a bit later in tickets. So we work with Jira, but other ticketing systems do essentially the same. You have an epic or a story, something big, and then you can divide this in subtasks or tasks, and you can each point to a certain person. This is now in Dutch, I see, but for example, this epic is about our move to the SIP 2.0 because we also version our SIP specification, and you can see that this has a number of subtasks, and this is one is in review, this one is done, other ones are selected for development, other ones are still in the backlog. So this is just very nice for ourselves because we have an overview of stuff that we still have to do and that is already done. And then this is the open editorial process. So we use GitHub for this, also in the slide at the end with the URL and everything, which is nice because you can have iterative commits that then result in a pull request that can then be reviewed by someone at the moment internally, but it's open. So you could also have, for example, a partner that reviews something. People can also have issues, so they can review the documentation or the SIP specification in this case, and then they can open an issue with a question or with a bug or with something else that they noticed, which is nice because then you can directly work on that issue, have commits linked to that issue, open a pull request to get the updates into the main branch for the new version of the documentation and so on. This is how we go about making it clear to partners what version of the specification is still being supported. So we have a number of versions going from editor's draft, so basically bleeding or cutting edge in software speak, that then moves on to release candidate. Basically, it's almost stable, but we offer no guarantees yet. Then stable means that from our end, everything is stable, everything is finished in the backend to actually ingest stuff according to this specific version of the specification. And then, of course, over time, a specific version, an older one, gets deprecated. So we still support it, but yeah, it will get not removed, but it will get retired in the near future. And then retired is we don't ingest stuff that uses this version of the specification anymore. So this makes it also clear to what they can expect from our end. And also for ourselves, it's quite useful because then we can work in the open on something new, but signal it as an editor's draft so people don't have the expectation yet that it's finished or anything. Then I will take a sip of water, so I will speak a little slower. This is the versioning that I talked about earlier. So we decided to version our specification, just like you can do with software, in which we started with a 1.0, which had the basic profile that I showed you earlier and just contained simple video and audio. That one has been retired in the meantime, and now we support the 1.1. And very recently, because on the documentation it's still as a release candidate, but actually internally it's mostly stable as those things go in software land. So we support these two. 1.1 introduced support for digitized artworks. So we added a content profile for material artworks. And then the 1.2 added support for written works, so newspapers, but it's actually a larger bibliographic profile. So if you have a book, for example, or in our case, a manuscript that was digitized, that can also use this profile. And then in the hopefully near future, because we're still analyzing this, we are aligning more closely with E-ARK 2.2 that I think released in May, so something or around the early summer, last summer. And that also added the E-ARK compliance seal that we want to apply for, because I haven't really talked about this at the moment because it's not that important, but our 1.x version of the specification added something that was actually not fully E-ARK compliant because we had a luminous ID, because we were still young and naive, to wrap the entire E-ARK SIP in a bag using the Baggett specification, because we thought of use cases in which a partner wants to deliver multiple zip packages that still had a link on some level. So to signify that link, we added the bag on top of it, so they could still actually, because it's still supported in 1.2, use a bag with multiple zips in it. But over time, we have seen that partners don't really have a need for this use case, and it actually makes everything a lot more complex because you have, on top of the E-ARK specification that is already quite layered because it follows this notion of files and representations and intellectual entities from premise, you have another layer on top, which is the bag. So it made everything more complex. So we realized that we needed to get rid of it. So in 2.0, we are actually removing this layer, and we will now be fully compliant with E-ARK and can then finally apply for the compliance seal. And then to separate the concerns, so to speak, we already added a new content profile for digitized film that I talked to you earlier. We added that in the 2.1 just for separation of concerns. So it's clear to our partners that we are still working on 2.0 and not yet on the 2.1. I will go a bit faster. So this is just about the governance model, because with all this versioning and these labels that we work with, we can have a clear, or we're still working on this governance model in which it's clear that we can release a version, we can collect requirements, we can draft specification, people or ourselves can review this draft, and so on and so on. And then ingesting the SIPs, so how we transform it to a graph for semantic validation, which is something we added ourselves. And I hope that this is legible, otherwise I will try to do this, and I hope that this will work. So we here you can see, in general, this is an overview of the 1.x flow. So this is still the old flow, so to speak, not the 2.0 flow, in which a CP can deliver material, SIP in this case, to S3. It gets transferred to a VM that will then get on the VM unzipped. Then after this unzipping or unzipping, to add a word joke, we validate the back because we still use it. Then we do this syntactic validation that most people will be acquainted with, in which we validate the XML files with XSD files. We construct, that is our semantic validation. We construct an RDF representation of our SIP, so basically a linked data version of our SIP. And then we validate this with SHACL. And then once all the validations are okay, we transform the SIP, because we are still bound at this moment to our media asset management system, which is MediaHaven by Ziticom, that has also a specific requirement for the SIPs that they ingest. So we transform it to their SIP, and then we transfer it to our media asset management system. So perhaps also interesting about this is that each of these boxes signify components or microservices, which are small components of software that each have one and only one dedicated task. And they are linked via events, which are these little envelopes in the diagram. So once a microservice, so once a box finishes something, it can signify via an event that it was successful or failed. This event is then kept by a so-called event broker, so basically a service that lists all the events that it gets sent to, and then the next microservice or component can listen or can ask this event broker, so basically what is new for this topic, and then it can add its own microservice or its own function to this, and so on and so on. So this is a bit more comprehensible, perhaps. So we have a partner, they have material that they can deliver at the moment via a visual tool. So they can deliver the SIP via a visual tool very manually, or they can deliver it via the API integration. These boxes signify a finished SIP. So in this case, we expect that if they use the API integration, that they deliver a well-formed SIP via the API. With the visual tool, they can use other means, and then the tool transforms them to a SIP. And then to B, we currently have a tender for ingest tooling. We want to have something like the visual tool, but on a larger scale. And all of these can then deliver their stuff to the S3 bucket that will then trigger the flow that I showed you earlier. I will leave this out. This is just, again, how the premise stuff works. Just of note is that we also added something like a digital or a carrier representation on top of the general premise representation to make a distinction between stuff that contains digital files and then carrier representation that contains information about the analog carrier. This is just a beautiful visualization that you can review afterwards for a so-called film reel of the Titanic and how it could be represented. This is the syntactic validation, in which we unpack the SIP in XML files and in like the abstract folder structure. We validate these with our XSD files. And then we also validate the folder structure with our with the E-ARK SIP rules and our own validation rules. And then this is what I actually wanted to come to. So then the semantic validation. So basically we have XML files in the SIP. We transform them into a graph using SHACL, which is a query language for linked data. And then this linked data representation is validated with SHACL using the content profiles. So this will become a bit more clear, perhaps. What we need for this semantic validation is we first need to transform the XML data into RDF or linked data with SHACL. And we need the content profiles that are requirements based on XML to be translated into SHACL models. SHACL is the Shapes Constraint Language from W3C that is basically XSD for graphs, but more detailed. SHACL can validate the relationships between elements. So you have stuff like a newspaper must consist of newspaper pages. The total number of pages of a newspaper cannot be more than the number of pages it consists of. In addition, can belong to a series. A page can have a height and a width, but those cannot exceed a certain amount and must be expressed either in millimeters or centimeters. So yeah, complex stuff that SHACL can handle and is not possible or not easily possible in XSD. So this is time to pray to the demo gods, because I will try to show you a little demo in the hope that it will make everything a bit more easy. I will do this like this, and what I will try to show you is perhaps I'm checking perhaps this slide. So I will focus on this part, right? So I will locally fake an event. Recall from the microservices that listen to events, I will fake an event that will then trigger locally on my computer the semantic validation step. So if we go to the code, this is not very interesting perhaps, but just to show everything in the open, I will fake this event here. So basically I will focus on a good flow now because it's more interesting. I will just run this. So it has now sent an event to the event broker. And then I will check this, in which basically I trigger the semantic validation step. So you can see here we use the library SHACL anything to convert the XML into the linked data representation into RDF, and it's now done. So then if we go here, I can now send to the API that is locally being run on my computer a call to investigate, I think, just to check, this is not found, but I think on position 5 it should show. So this is an example of the event after the semantic validation. So what it shows, it's a lot of text, but what it shows is, most importantly, it has data. That data shows that this graph is conformed, so it has it validates semantically speaking, and this is the graph data actually. So it's a lot of data. It's basically the SIP in linked data version, formatted as a turtle file. I am close to the Q&A session, but I will take 5 more minutes just to show you a visualization of this, because this is not interesting, right? It's nice to have a text representation of this, but not very nice to work with. So what we then can do is, I have a little bit of code here that is also too small, but I will run this all. So what I do is I read the input data, I clean it up a little bit, and then I make a graph locally. And then you can see this graph that I showed you earlier. It has 499 triples. So yeah, if you know RDF, you have a triple. Each triple is a subject, a predicate, and an object. So I, as a person, is a subject, have a name, is the property, and my name is Milan, so that is the object. So everything works like this in RDF. Here you can see the raw data then. So everything has a subject, a predicate, and object, but this is still not very nice to work with. So what we can do is we can create, I will just open this in my own folder here. I have to think a little bit where I put this. So here, this is the output of a visualization. It will not show you very much because it's very all over the place. So this is the graph data that I visualized, but just to make it a bit more interesting for you, I marked it up a little bit. So I will show you this, and then I will zoom a little bit. So what we have here in orange is, I think, or I hope that you can see this, is basically the graph representation of the SIP as an abstract concept. So we have something here on top that is a SIP. You can see this here on the right. It's somewhere it should say that it is conform. It conforms to the bibliographic profile because I ingested a newspaper SIP. And then if we zoom out again a little bit, here on top, you can see that we have a newspaper title that has a certain origin date. This is all fake data, so don't mind the dates. That has a number of pages. It has 4 pages. Then it has a number of licenses here below. And then it has representations in premise speak. So this, for example, is a representation of this intellectual entity of the edition. It has a representation number 2, and it includes, for example, a number of files. It includes the Alto-XML file. This Alto-XML file is 946 bytes large. It is position 4, so it is page number 4. And then if you go down here somewhere between all the stuff, it has an MD5 checksum here with a value. Then this is the same. This is representation 1 that consists of the TIFF files. So this is here, for example, and so on and so on. Yeah, basically that. I will just go very quickly through the rest of the presentation. So that was that. And then, as I said, we transfer it again, or we transform it again to a SIP that our media asset management system can handle. And then just briefly the way forward. So our specification, although in our feeling it is already readable, it is still a hurdle for a lot of people. So throughout our interactions with a number of people, we noticed that the current specification is still a metaphorical bridge too far. The UI of our developer docs is a bit too clunky to navigate this efficiently. And then you also have common struggles. So we use linking IDs throughout the SIP to link, for example, the descriptive metadata to the intellectual entity. And people don't really grasp this concept. And then we are also looking into improving the accessibility, so less formal how-to sections, so even easier ones, better documented samples and context, and also decouple the samples into a separate repository because we also want to share them with other people, for example, from Premise, so they can also have information about how to use Premise and so on. Then further integrating the E-ARK tooling, we want to make more use of the existing E-ARK tooling, like the Commons IP library or the E-ARK validator, and contribute ourselves to these repositories. And we want to apply for the conformance seal. This is just a funny seal of approval. And we are also participating currently in the AIP work group using JSON-LD, because we are undertaking small steps for ourselves towards a SIP Lite in RDF linked data, so a fully SIP in linked data, because we have this knowledge graph at the moment, which contains a linked data version of all our metadata in the archive, which would play nicely then to ingest the SIP directly into that. We are also preparing the transition towards the 2.0 that I told you about, and also the validation methods that I showed you. It's all nice and it works well, but you have to know the SIP literally inside out. The validation reports that you get are very confusing because the validation report talks about the linked data version, but then it's very hard conceptually to link an error in the validation report in the linked data version back to a specific line in an XML file. So we are looking into decoupling the syntactic and semantic validation. And these are just the links that I told you about that you can check out later. And that was it.